Okay, it has reached the bottom of the hour, and that's when we're meant to start. So let's do so, respecting everybody's time for those who came on time. Welcome to the CBOR Working Group at IETF 123. I'm Barry Liba, and on the screen is Christian Amsus, and we are your friendly chairs. I believe we are in the process of getting a third chair, and we'll see what happens with that as our AD proceeds with that. So let's go through the administrative stuff here. Okay, this is doing. Yes, so note the note well. These are the things you agree to in order to participate in an IETF activity, and you should know what those things are. So if you aren't aware of it, please read in detail later or before or whatever. Also note that we treat each other respectfully here, and we expect everybody to do that. So these are some of the guidelines for that and references to the appropriate documents saying. If you are attending either remotely or in the room, please get on MeetEcho. You can get on MeetEcho by scanning the code that's hanging from the microphone up there. Unfortunately, it disappears from the screen when we start doing things. But it is on that, and you can also get to it through the agenda and various other means. If you want to say something even in the room, please use MeetEcho to get in the queue so we can interlace you with the people who are participating remotely. Okay, so that takes care of the first item on the agenda. We can bash the others. Martine is first with the CBOR, DNS CBOR discussion. So yeah, come up and get ready as I go through the rest of the agenda. We haven't gotten any slides from Tahina. Are you in the room? Oh, there he is. Okay, so you can happily talk without slides. That's fine, and that will be after Martine.
Actually, I think it makes sense if Tahina talks first, because my talk will a little bit lead into the discussions we want to have later. So.
Perfect.
That there isn't that much of a gap.
So we have just had some agenda bashing. We are switching items 2 and 3 on the agenda. So Tahina, you will be first. And do you want to say something?
Yes, I do have slides, but I probably sent them to the wrong person. I sent them to Carsten. So.
Oh, okay.
Yes.
Yes. So we have a slide thing going on here as we go through the agenda. And then we'll talk about anything that we want to say that happened at the hackathon, and then get into the main part of the meeting, which will be the discussion of the remaining issues on the 3 documents. I had meant to go through them in the order that they're listed there, CDE first, then PAC, then EDN literals. I am happy to change the order if there's a reason we should do that. So we can hit that when we get to them. I believe that Karsten's slides are in a different order, and I'm fine with that. Whenever we're ready on the Ever CBOR stuff, we'll go ahead and get started. In the meantime, you can listen to Karsten sing or something.
At first I was afraid, I was petrified.
Ah, we have Rowan singing. That's even better. And he will survive. Perfect. All right, well, let me go switch to those slides.
Yes, sorry about that.
So that is Ever CBOR. There they
Yes.
are.
Is there any remote control or anything, or
Do
should
that.
I?
There's a clicker there, and I
Thank
believe
you.
I have to
Set a clock, please. Yes.
Where do I do that?
Find the slide clicker in the participants list.
There we go. Yes.
Slicker has control.
Thank you.
And someone has done that for me. So, okay.
Thanks a lot. Is there any clock to set up, or? Thank you. Is there any clock to set up?
No,
A timer.
I will
Okay. Thank you.
throw something
Thanks a lot. Hi, my name is Tahina. I'm from Microsoft Research in Redmond. Thank you for hosting me here for the CBOR working group meeting. I will tell you about our formally verified implementation of CBOR and CDL and COSI. So what do we have? We have Ever CBOR, which is a verified parser and serializer for CBOR, which we wrote and proved correct in the F-star proof assistant and the functional programming language that we extract to C or Rust. And then besides, we also have, on top of Ever CBOR, we developed Ever CDDL, which is a verified automatic code generator for CDDL, which we wrote and proved correct in F-star. And so that the user just needs to provide a CDDL data format description and push a button so that Ever CDDL generates C or Rust code for a data type, a parser, and a serializer, which we have made enough for COSI and other protocols. I'll tell you which ones later. Ever CBOR and Ever CDDL are part of the EverParse project, which is open source, available on GitHub. We have a paper that was just accepted to ACM CCS this month. And you can also have a look at the more detailed presentation that I gave at the side meeting on Tuesday this week. So EverParse and Ever CBOR are part of a larger project that is called Project Everest, which has consisted in 1 million lines of F-star code and proof, cryptography, verified parsers, and so on. The projects of Project Everest have been deployed in the wild, Linux, Firefox, Python, Windows, and Azure. And Everest has been open source. Even though the Everest project itself has been deemed stopped, its offspring, including F-star, EverParse, and other projects, have grown up as active standalone projects that are actively developed as of now. I gave a broader talk on EverParse at the Usable Formal Methods Research Group yesterday, yes, and you can have a look at the presentation there if you want. So Ever CBOR and Ever CDDL, what is the user, what do we intend for the user experience to be is that either they use Ever CBOR directly by just calling into the library. So this is one possibility. Or they write a CDDL description and then they push a button. And then when they push the Ever CDDL button, we automatically generate F-star code, which will be a formal specification of the CDDL description and verified implementation against that specification using the Ever CBOR and Ever CDDL libraries that we then extract to C or Rust code. We provide the following formal guarantees, such as memory safety, arithmetic safety, that is no integer overflow or underflow, functional correctness with respect to that formal specification, non-ambiguity, and when using the deterministic subset, the deterministic encoding of CBOR from section 4.2, non-malleability, that is unique binary representation. So currently, our implementation is supporting the deterministic encoding of CBOR without a floating point. We plan in the next few weeks to support non-deterministic CBOR and floating points, at least for the definite length. We'll try also something for the the indefinite length, but we have to be careful with stack consumption during validation. Which we have managed to do in constant stack space for the deterministic encoding. We strongly believe that it is also possible to do validation in constant stack space for CBOR objects where there are no maps in map keys. But in the general case, we believe that we will need to do some stack consumption. We will need to consume probably unbounded amount of stack. We do not do any heap allocation at all across Ever CBOR or Ever CDDL, in the sense that parsers provide iterators for arrays and maps. And it is the responsibility of the user to allocate any space for the object when they want to serialize. which we allow users to serialize the CBOR objects to build the CBOR objects in any order they like, and then we serialize them. But then it's the user's responsibility to manage the allocation of their objects. When we serialize from value of a data type generated by either CDDL, to ensure that the parser we parse back into the same value, we need to make sure that we fulfill the non-ambiguity constraints, so that yes, Rohan, you have a question?
Oh, you could have finished the slide, but it was about stack usage when
Yes.
you have arbitrary depth.
Yes.
Do you have a way to sort of restrict the depth of nesting?
Alors, we could, but there is a more philosophical question there. Is it desirable? That is, how should we compare between an attacker and a legitimate user who sends a valid packet even though it is deeply nested? So it's more of like a philosophical question. We can always bound with a fixed bound, but it's not always desirable for a protocol. So that's a wider discussion that I would like to have.
Okay. Yeah, my opinion is that if it's a library option, or if it's running it as a command line tool, if it's a command line option, that's perfectly appropriate, and you can decide it based on the profile that you're using.
Okay, thank you. I think, yes, I believe we will do that anyway, but then, yes, we have to be careful about whether it is desirable. Okay, thank you. Thanks a lot. Yes, secure serialization API for ever CDDL at least is that, for instance, if a user has if you have a CDDL description with a table and some other entries before, you don't want, for instance, entries in the table to have keys that clash with the previous entries. So the serializer generated by ever CDDL will gracefully exit and reject the input object in that case, instead of requiring it as a precondition or silently generating a CBOR object that would have duplicate keys in the map. So that's what I mean by a secure serialization API, is that you ask to serialize your object, and the serializer will reject it if it happens to lead to duplicate keys in maps. To do that, sometimes we can also avoid such dynamic checks by performing partial compile times disjointness checking in the CDDL specification, which amounts to basically proving non-ambiguity of the CDDL specification ahead of time. The performance of ever CBOR and the generated ever CDDL code is in the ballpark of QCBOR and tiny CBOR, in the sense that yes, we have some slowdown due to the handling of nesting and lack of specialization while doing serialization. But we also, thanks to deterministic encoding, we also have some speed up in map lookup, in the sense that we know when we know that a key is smaller than the current map entry in the map, then we can abort and say, yes, there is no entry for that key, by virtue of being able to compare objects for the deterministic encoding without serializing them. So during the hackathon this week, and I like to thank every one of you here and also in other protocols using CBOR and CDDL for providing me with more CDDL specifications to test ever CDDL with, such as CWT, EIT, and some drafts for ACE and core. And I have still a long list from that hackathon and the discussion on Tuesday to continue testing with. And I managed to support most of those features. I had to rewrite some for currently unsupported features, such as syntactic transformations, but I pledge to support them in the next few weeks. The major feature that I am missing right now is recursion, in the sense that I have to unfold bounded recursion in COSI. And for EAT, whether I can do such unfolding is still to be seen, but by Rohan's suggestion, if I add a bound, it might work. But the discussions that we had on Tuesday showed that adding such a bound is not necessarily desirable. That is, we don't know in advance how deep are, for instance, nested tokens or submodules in an EAT, or in we will need to do something there to avoid stack exhaustion or anything. So voilà, the discussions are still open on that side. But that's basically the main reason why we don't support recursion in Everc DDL, is that we don't know how to make sure that an attacker will not try to craft valid packet, I mean valid or invalid, but deeply nested packet to exhaust a stack of the validator. In this process, I discovered some inaccuracies in existing CDDL descriptions, mainly missing cuts in map groups next to extension tables. For instance, in COSI header map, Karsten suggested me to submit an erratum to insert cuts where they are missing, and thank you again. I will do that in early August when we come back from our respective vacations. So that everyone can review the erratum with a clear mind. But this pattern has been more invasive than I thought. Even I found it in ad hoc information when I looked at the draft during the hackathon. And some other non-IETF protocols also use that pattern, even though this pattern may be desirable in some cases where, for instance, you want to be able to extend the type of value for a given key. It's in most cases not. So this is one thing we will need to have more discussions in the future for CDDL description designers. Also, the interpretation of CDDL, as I clarified with Karsten and others, that it should be PEG, and it is not the case in COSI, where the field has been interpreted in more like in a non-greedy way. And so, for instance, here, if we intend to have, for instance, a SIG structure with only 4 fields, then the third field might be caught by a sign protected, and then greedy PEG implementation of CDDL will fail a validation of such an object by expecting a payload where there is none. And I also managed to express some constraints in COSI that are in the normative text, but are claimed to be not expressible in CDDL, whether they are. For instance, the fact that the keys 5 and 6 in a header map cannot be present together. Using an empty symbol, say, such as an empty range, to support that key is not present. You can see the details in the detailed presentation or in our Everc DDL implementation. Voilà, so we claim to have with Everc CBOR and Everc DDL interoperable and reasonable implementations of CBOR and CDL with strong formal guarantees, of course, with some improvements needed in the next few weeks. Or we mean to remove the need for handwriting parsers and serializers, at least for CDDL defined formats, so that people can use automatic Everc DDL code generation with our strong formal guarantees. We have led to improved understanding of the CBOR deterministic encoding and of CDDL alone. I will follow the discussions on floating points for the deterministic encoding, which will have an impact on my implementation in the next few weeks. And as you saw, we have also led to a clarification in CDDL descriptions in existing standards. And I'd like to pursue this effort all across the standards in IETF and outside, because I'd like to have CDDL descriptions in standards that can be used by Everc DDL for automatic code processing, for automatic processing. So once again, EverCDD CBOR and EverCDDL are available as part of EverParse, which is open source, available on GitHub. And if you have any questions, please email me. I'm Tahina. Thank you again for your attention.
Thank you. And we have about 5 minutes for discussion of this. Karsten, hit it.
Yeah, it was fun to spend a hackathon weekend, at least in part, with this. And the experience, the user experience was that Tahina more or less gave me a guided tour of all the places where we try to sweep things under the rug. And his tools found those. So I think this will be really useful. Can you go back to slide 7?
Alors, c'est 7, oui.
So the 2 examples there are from RFC 1952.
Yes.
Which is maybe one RFC where we were slightly more prone to sweep things under the rug, because the situation in which this RFC was completed was somewhat difficult. The first example, the header map there, is not wrong, but it's just not as selective as it could be. So by putting in the correct cuts, we can get better checking of what is in the header maps.
Yes.
So just as an observation for people who haven't followed cuts that closely. The second example is somewhat special, as this structure is never validated. It's only generated. It's not sent over the wire because it just goes into a hash value. So there is no code that will stumble over this problem. That's why nobody has come up and said, my implementation fails. It just doesn't happen, but it's still wrong. So I think the second one really is one where we should have an errata report. You didn't put the corrected
yes, I did not. Yes.
on the slide. It's a pretty mechanical transformation that makes this thing valid again.
Okay, then are you suggesting that that I should also send a separate erratum for that?
I think SIG structure is the only one that actually is an erratum.
Okay, sorry. Okay, then
the other is more like an observation about not using the functionality of CDDL as much as it could be. And I think this might be the trigger for just an effort to look at all the other places where cuts really should be used to get the selectivity that we want. We put this into CDDL in 2018, 17, I don't remember, knowing that cuts are not necessarily a concept that people have learned in their CS education, if they have CS education at all. So it's pretty obvious to someone who works with formal languages, but it's maybe not so obvious for other people. So I would propose this as a trigger point to start a campaign to do the cut thing with a little bit more attention.
Okay.
Thank you.
Thank you.
Okay, Jeremy.
Yes.
Have you looked at any of the recent extensions to CDDL? So I know that you describe this as effectively as being RFC 8610, but we've got quite a number of extensions to CDDL, some of which are published, some of which are still in draft. Have you looked at any of these from the perspective of formal verification yet? Or at least the thought that they look reasonable?
I have not made a list of them, and I looked at some of them, but not all. .CBOR, yes. Range, yes. I mean, .size, yes. .end and .within, I believe that I can implement them easily, even in the serializer. And for the rest, I have not looked at them, but thank you for your suggestion. I know that I have seen also .features somewhere recently, but I have to look at it, what it means. And thank you again. Yes.
Karsten.
Yeah, just a quick comment. This is just a very nice example of the extensibility discussion we will have in about an hour from now. Those control operators are an extension point. So lots of people can come up with them. We have a couple of RFCs that this group did. We have other RFCs that also are defining control operators. So there is not necessarily an expectation that a tool that supports CDL supports all control operators because some may be application specific. But of course, it would be nice to have those that are really in the line of RFCs that define a CDDL, when those would have some support. And I would really love to do the next suite of these control operator registrations after applying some formal specification to it and not before doing that.
Yes, thank you.
Jeremy.
So I'd like to come back a little bit on that, because if we see CDDL as a tool for specifying protocols and formats over the wire and the like, it's extremely desirable to generate those in a way that is ideally formally verified and that can be bounded, and all of the things that tools like CDDL can do. The problem is that the further I suspect, but haven't proved, that CDDL is already quite close to Turing complete, and the more that we have specifications for additional operators that are being designed to solve usually problems of specifying particular RFCs neatly, the more difficult it becomes to have tools that can generate code for these in a straightforward way. So I would actually urge working the other way and really saying that new extensions, as at least to be adopted as RFCs, need to show that they can be integrated into, well, the usual rule is at least 2 tools, right? And to work in those contexts.
Alan, and then Kirsten.
Yeah, this is Alan. Nice work. I like it.
Thank you.
I have one question. Looking at the GitHub repo,
Yes.
there doesn't seem to be a lot of tests put in there. And one question for people with other implementations, is there a way for them to leverage this work to test their own implementations too?
Alors, for the test part, at least I have the test suite from a couple of years ago for CBOR, which are supporting, I mean, there are something like 29 of them, I think, supporting deterministic encoding. During the discussion on Tuesday, I got more links to further test suites, and I hope that these test suite can be gathered at some single place at some point, which will be beneficial to everyone, not just ever CBOR, ever CDDL. And for CDDL, again, yes, I have a branch that has those tests shown in this slide. From the hackathon, and yes, thank you for your suggestion. And yes, I hope we can have such tests centralized somewhere.
Yeah, in the course of writing the 3 current working group documents, there have been lots of test vectors generated, but currently specific to those drafts, and maybe that's another campaign we need to start after this meeting, consolidating our test vectors and putting things together. I would like to say something to what Jeremy said. Yeah, so we have some CDL control operators that may not have as much tool support as others. The outcome you get from not having the control operators is that the necessary information is specified in English, which really is not helping at all. Specifying the things is better than not specifying it, and having tools for them is better than just specifying them. So that's why I said we really should look for doing this work, but it should not be a gating function.
Okay, I reopened and relocked the queue. So we have Rowan and Lawrence, and then we're done with this topic.
Yeah.
Rowan.
I just wanted to say, when it's time for you to do recursion,
Yes.
I would love for you to test out the Mimi content format, which has nested body parts, which are in C.
Which one? Sorry.
The Mimi content format. It's draft IETF Mimi content.
Okay. Thank you. Thanks a lot.
So just a quick comment on test cases. CBOR has hundreds of test cases, maybe 1,000 in all told. And, you know, fuzzing input to that, and, you know, some of them are very specific to the APIs and all that. So, I mean, you know, a full test suite here is actually quite large, and, you know, the stuff in CBOR, of course, is anybody's welcome to look at it. It's not particularly organized for, you know, reuse. Some of it is, but anyway, just calibration on test cases for commercial software.
Thank you. Yes.
Okay. Thanks everybody for the discussion, and thanks Tahina for bringing this to us.
And thank you all for hosting me again. Thank you again for hosting me. And yes, thanks a lot.
Okay, Martin, it's your turn. So that's, we want, okay, which slides are we looking for here? Oh, is it this one? Yes, it's that one. It doesn't say on the few letters that I get
Okay.
to do that. So,
Okay.
So go ahead.
Yeah. So hi, I'm Martin, and I'd like to talk about my DNS message format, or rather the packed requirements and some evaluation we did for that, so that it might motivate the discussion later on. So first I will give a recap of what format we're talking about, what happened in packs since we started, then present my evaluation, and then conclude my talk. So first of all, DNS plus CBOR is a format that represents DNS messages, and it uses packed CBOR by, first of all, by introducing name compression using the table setup tag 28,254.59. If you write this out in binary, that will result into the mnemonic NC. And it introduces a virtual packing table containing all name suffixes in the message, and then repeated name suffixes then are just shared value references to this virtual table. And we achieve this by having the splicing integration tag, which allows the insertion of sequences into existing lists. Then we also introduce further compression using this packed equals 1 parameter, which is using table setup tag 113. And that provides also straight references for IPv6 prefixes and shared value references for repeated values such as DTLs, RR types, or resource record types and resource record classes. And we put all these implementations already, and no, that's later, sorry. So what happens in packed since we started with our draft? First of all, the number of allocated tags and simple values was reduced. Actually, the current packed CBOR is parameterized. So there are these values A, B, and C. A is the number of simple values that are used for shared references. B is the number of 1+1 tags that are used for low index straight references, and C is the number of 1+1 tags that are used for low index reverted references. For higher index, there is this tag 6, which is basically then encapsulating a list with, or an array with an index and a rump. And if the index is positive, then it's a straight reference. If it's negative, then it's inverted references. In the past, this used to be expressed by this 1+b, so longer and bigger tags. And in the past, Carsten floated some proposals around what A, B, and C could be. originally, of course, it was A equals 16, B equals 32, and C equals 8. Then there was this radical approach. It didn't say anything about A, but B and C were 0. Reduced would be that then B would only be halved. And the economic approach, which she presented at the May interim, was that B and C equals 8. And in the latest interim, before the meeting, he then also gave the value for A, which was 12. So for our evaluation, I used the data corpus of several DNS messages that come from an IoT data set that we composed from the artifacts of 3 studies. They were collected throughout 2019, contained DNS and MDNS traffic, and were basically not the classical constrained IoT devices, but consumer-grade devices such as smart plugs, smart TVs, and stuff like that. But it contains 2,336 unique queried names, several queries and responses. So just to give you an idea how this is composed, I won't get into much detail with that, but we see, oh, that's very badly seen, but yeah, look at maybe at the laptops. I see it very in higher contrast. So yeah, but you see at least the median lines, and these are the ones I want to describe. So for we have IPv6 name suffixes, which are like about 12 bytes long for the most part, and IP prefixes in the IPv6 are 7 bytes in common and per message. And for IPv4, it's only 1 byte, so there isn't that much to be saved with IPv4. Yeah, and as a reminder, this data set was already used by Carsten in a previous presentation, where he basically showed when A is given, what share of messages has all messages covered, and there we showed that about 95% of the messages are covered, of the suffixes, 95% of the messages have all suffixes covered when A is 12, but as you can see, there's also this small uptick still if A equals 16. So what did I do? So I basically just looked at the message sizes for name compression and packed. For name compression, we only use shared value references, so A is only relevant, and for packed 1 equals 1, only A and B are relevant because we don't use inverted references there. And then I parameterized my DNS plus CBOR implementation, CBOR for DNS accordingly, and ran with it. So this is the results. As you can see mostly very little differences. So the tails get a little bit shorter when A equals 8, and you see the shape is a little bit different. But all in all, it's very hard to see. So I also looked at the statistics directly. So here you can see basically grouped by how well the message is compressed for A equals 0, for 8, 12, and 16. And you can see the best compression we get with as of A equals 12, because with A equals 8 we have this one number that is just a little bit bigger. We also did this. Also did the same evaluation for packed then with B and A. So A is this time in color, and B is on the x-axis. There we even see a very much smaller difference. Again, going into the statistics here, we mainly see some changes in the, but very minuscule changes in the mean and the standard deviation when we increase our A. But in general, B larger than 8 is the best compression for that. And when we increase A to 16, our curves get a little bit narrower. So in conclusion, in general, we can achieve compression with even the radical approach. I didn't show that, but we had like between 10 and 26 bytes saved when only using name compression, and between 8 and 314 bytes saved was packed. What numbers should we pick for A, B, and C is a little bit just when we where we can talk about like minor differences. In my opinion, it should be over 8. For 12 would be a good compromise, but 16 also has benefits because we saw this minor uptick there. And when it comes to B, that's basically just micro optimizations, but I think B greater than or equal to 8 would be sensible. C I did not evaluate, but in my opinion, it should be similar to B because that makes implementations easier. So, any questions?
Just a quick comment on deriving recommendations from these tests. So the data that you have is about DNS requests and DNS responses,
Exactly.
which are not the smallest items we are exchanging with the CBOR, but also not the largest one.
Yes.
So for that particular part of the spectrum, those recommendations here are good. But we might also want to look at larger messages, and those tend to consume more table entries. Yeah, we know a lot more now, but we haven't covered the entire spectrum. And I'm not even sure that we have to, because this is certainly a case that is pretty dominating in its meaning for the constraint space. So it's a pretty good basis to work on. But keep in mind, that doesn't mean that larger numbers wouldn't be nice, but we had some discussions and there have been reasons to reduce these numbers from the original proposal.
Further questions?
Yeah. Any further discussion?
Juan, you were in the queue before?
Okay, I guess we're good. Thanks, Martin.
Thank you.
Okay, Karsten or anybody else want to talk about what happened at the hackathon and anything more we need to say about the hackathon? Should I just bring up your slides? Or? Okay.
I can't go to slide 31 with a clicker.
Go to slide.
Okay, Karsten's slides, and the clicker is on it, but yes. Well, let's try that again. I thought, that's odd. Try this again. Okay, there we go. So where do you want to?
31.
31. There we go. Okay.
Yeah. So beside the question, how well do the messages look like that we get from the compression? Of course, for something that goes into constrained devices, we want to have an idea of what the implementation size is. So we have, well, you could talk to that, but let me do that. So we have, Nikolai has an implementation based on the Nano CBOR library, and he put in first pack shared, and then the integration tags idea that we recently have developed here. The integration idea is pretty new, and it's first of all good to know, yes, this can be implemented without losing too much hair. Yeah, let's look at the actual numbers. So the lines of code for the CBOR base implementation is 500. Adding the packed shared code adds 300 lines of code. And actually the space expands a bit more because you actually need additional buffer spaces and so on. Yeah, it almost doubles. The size of a context, which is essentially each level of container nesting that you have opened during the decoding, that goes from 24 for just base to 48 for packed shared. And next thing, adding integration tags 56, another 100 lines of code, another 500 bytes of code space. So of course, we would all be very happy if this could be done in 11 lines of code, like some of the other stuff I will talk about today. But yeah, 300 is not a disaster, and 400 isn't a disaster either. And well, the code space, you actually have to pay for getting some improvement from the pack. So one comment that Nikolai made is on the lower right there. We have given integration tags a lot of leeway what they actually mean, because it's an extension point, you can define new integration tags and they can do complicated things. So by giving this flexibility to integration tags, you will require more work for handling those specific semantics. So for instance, the decoder context could grow further if we invent more integration tags. So we mostly invented that thing just to address Vadim's thoughts about not using up all the shared items or the simple value tags, simple values for shared items. And we already have done a bit there by going to the number 12. So I think this is still useful. So we can give some of these 12 simple values to some other usage that is not exactly CBOR packed. But we have to keep in mind more flexibility equals more complex code, even if you are not using the flexibility at the moment. Anything I forgot? So thanks to Nikolai.
Okay, so well, now we're into discussion of the documents. Are you okay with the order that I have them in, CDE and then packed and then EDN literal? So let's start off. Do you know offhand where your slides are for what?
Yeah, so
where I should
the
go?
other packed slides should be in the vicinity here.
Okay, let me.
I can click around it. It's not many
Okay,
slides.
I'll let you
But
do
have
that,
to
and then.
give me the clicker.
Oh, well.
Okay, basically the idea is that we
Go ahead.
will do the easy ones first, assuming they are easy. But if if it turns out to be hard, we should spend most of our time on EDN literals. So let's see whether we can actually do this quickly. So looking at packed, Martin has already talked about A equals 12, B equals 8, and C equals 8. I haven't heard any new opposition to these numbers. Of course, different people have different ideas how we should spend these resources that we are spending here, simple values and tag numbers, short tag numbers. But it seems like A equals 8, B equals A equals 12, B equals 8, C equals 8 is a frugal way to work with this. And we are addressing Joe's original comment, which was essentially, that's a lot of tags. And yeah, it's now 16 tags in total. and 12 simple values. We have one implementation of integration tags. What we haven't done yet is doing some interop work. So it's probably a good idea to spend 4 or 6 weeks doing this interop work and make sure that the newest version of the document doesn't have big holes, and then go for working with us call end of August. So that would be my summary. Did I have another slide? Yeah, exactly. So this says more interop with integration tags, and then there are 4 remaining issues in the repository. 3 are editorial, not all of which are slam dunk editorial, so it does require a little bit of work to get rid of them. And 1 is technical, where we have the problem that different invalid values might be replaced by this tag 1112, and that can in turn result in an invalid document when those values happen to be map keys. We have to, I think, at least point out a value to handle this situation. It's maybe not the most important situation, but we shouldn't just leave this open and have implementers run into it without knowing what's going on. So that's a technical item. I would probably just put in, if your implementation wants to avoid producing invalid output, then put in a counter or something like that. So that's another technical change we would make. I'm not sure if we ever actually looked at this in interoperability testing. It's just handling an error case. Yeah, that's the one remaining piece of technical work I think we need to do. That's all I have.
Discussion? Okay, Christian.
Microphone?
Christian, we see you dancing, but you're muted.
Better now? Sorry.
Yeah.
Brief remark on the interop on 1112. I don't think that this should really be an interop case. This is more about a helper that allows a library to communicate with its users. But serializing this back into CBOR is probably a bad idea in the first place.
Okay. Nikolai?
Hi, Nikolai Guccio, co-author of the draft since a year ago. So there was this mail discussion with Vadim. I don't know how many of you followed the threads. I tried to nail the main points down yesterday evening again in a response to him. Maybe it would be nice if some of you could have a look at that email that I sent yesterday and see if you have comments on some of them, so we can clear these open discussion points.
Yeah, I skimmed them. They looked right, but I have to read them in detail. And in particular, we need to decide whether there's anything editorial that flows into the document.
Thank you.
Good.
Okay, I guess we're done with discussion on PACT. So let's hit CDE.
Okay, we had an interesting discussion in the last couple of months about how to handle NaN payloads, non-zero NaN payloads. And we have new information, so the world is turning while we have this standardized. And in particular, the C language will contain some APIs to work with non-zero NaN payloads. Oh, by the way, I'm talking about floating point, not a number. I probably shouldn't go right into jargon here. And we have made some choices. Actually, Lawrence was the one who kicked off that discussion with issue number 1 on the CBOR repository. And we decided how we wanted to do this in CBOR. That's in 8949. And looking at the new information we have, it seems that's still the best way to handle this. There is no good way because the standardization situation for non-zero NAND payloads is very murky. The IEEE didn't really want to make a lot of normative statements about this because they wanted to avoid making previous implementations non-conforming. But of course, that also means you cannot say anything. So interoperability with these will always be limited. So why do we care about them in CBOR? Well, it's part of the IEEE number system. And if you have a computation that you are taking apart into a distributed computation, and that computation is in terms of NANDs with payloads, we better be supporting that. So it's not maybe not something that is on the front of the list for a CBOR implementer to work with. But the main results is we have revisited the 8949 decisions, and it appears that they are the best we can do at the moment. There is also a pull request that specifically discusses how preferred serialization handles the non-zero payloads and gives some advice how to actually work with those. How would you use the get payload, set payload API that C27 is likely to define? So it's an aside, it's not normative, it just tells you if you do this, then you will have more fun with those new APIs than if you do it in a different way. So we probably should be merging this PR. So that's the technical work that happened as far as I can summarize it. And there was a lot of discussion about adding more text to the CDE document that is about interesting things, but not about CDE. And I would like to push back a little bit on that because, yeah, it's not the objective here to do a new revision of 8949 or write a book about CBOR. Actually, there is a book being written right now. If you look on the mailing list, the blockchain commons people have been starting writing a book. So I haven't looked at it yet, but I find it very nice that they do an open source book about that. So yeah, that's definitely one other channel to write up our collective wisdom. So we have had additions from the last working group last call that ended early this year. I don't remember, February. And the current text, which are explanatory pieces, plus a piece of code that actually tells you how to do serialization and encoding of 16-bit floating point number. We have decoding in 8949, but we don't have the encoding direction. And it seemed kind of a gap that would be worth filling. And that 10-line C code was really useful to nail down the NAND payload issue, because you have to change 2 lines to get the other interpretation. Okay, yeah, this is the new aside about how to use get payload, set payload. I don't know how many people in this room care about this. Please read PR 37 on the CDE repository. And yeah, it essentially tells you that some things are happening, which is a true fact, and you can handle what happens by following a certain strategy that is not fully defined here because it depends on which your target size actually is. Well, usually your target size is binary 64, so it's pretty actionable if you have this problem. Okay, I would like to reaffirm the reason we are writing this document. We want to have a single document that points out the best practice for deterministic encoding in CBOR. We don't have to write a new normative document because everything actually is written up in 8949. It's just hard to find. And I understand Tahinder that he didn't want to include floating point in his initial version because that's where probably the most dragons are. And the objective is to make this document useful for the CBOR application designer and for an implementer that still has to add deterministic encoding to the tool set they are building. And I would propose that we reaffirm that it's not about a general treatise about creating profiles. We have one document that this working group already has kind of pushed back that is trying to define a profile for CBOR. I don't think we should do that. And I also think we shouldn't provide a manual for doing that. And also we probably shouldn't do a treatise about serialization. That's really the realm of that book. Rohan.
Okay, so right now it's the way the document is written, it seems sort of ambiguous whether we are referencing or defining serializations. So we've got common deterministic encoding. Is that a serialization? It doesn't say the word serialization in that entire section. Then we have the preferred serialization. I'm guessing that's a serialization because it has serialization in the name. And then we have other considerations. So like, imagine, 5, 6, 7 years from now, we end up having, we end up having a common serialization. We end up having preferred serialization. We end up having, some additional serializations. Maybe we have a serialization that says you can do floating point, but no payloads, not a number of payloads. Maybe we have a serialization that doesn't do any floating point. What goes where?
Well, profiles hopefully go nowhere.
No, that's not acceptable. They can go in somebody else's document that's
Yes.
related to their thing that they do.
This working group should not make it its own business to define profiles.
Fine, perfectly fine
So
answer.
if you don't want to do floating point, that's a very good decision in a lot of embedded applications, but it's not a new version of CBOR. It's just that you are only implementing part of it.
Yeah, I don't think that in any of these examples, you would say that any of these are a new version of CBOR. They're just a particular serialization that is chosen. And in some cases, there may be some additional profiling that's done by some application of CBOR.
Yeah.
But okay, the answer you gave that seems a perfectly sensible, reasonable answer. I just feel like this is a bit word salad when somebody reads it if we don't say, hey, here are some concrete choices in this document that people can point at. I don't care if it's normative or non-normative, but I think people are going to want to be able to say, I'm doing that thing here.
Yeah. So my recommendation would be for people to not point to the RFC that we are creating here, but explicitly point to section 3 of this RFC.
But I think
Go ahead, Barry.
I think Rowan is saying he thinks text in here is unclear. Yeah. or
Or
needs.
just the way that the text
Right.
generally is structured, it's like even after reading the whole section, all of section 3 like 4 times, it's still like, what do we call these things?
So my suggestion, Rowan, would be to ask you to propose text that you would like to see changed.
Yeah, I mean,
And-
I'm happy to go propose some text, but like, I don't want to enter the knife fight.
I understand.
So
I'm
how about
hoping
y'all
that-
decide what you want the result to be, and I'd be happy to write some text
Mm.
that says that.
I'm hoping that we avoid bloodshed here. And somewhat in that line, Lawrence, do you want to get up and I will put your slide up for a minute. Lawrence took a stab at a slide to sort of frame the discussion here. So I'm going to put that up and let him talk about that, and then we can continue further discussion. Okay.
Yeah, this is from this morning. This was the gray there is an attempt to characterize how I understand this stuff fits together. So I understand preferred serialization basically is 3 things. It's the shortest encoding of numbers, arguments, and floating point. That's one of them. Another part of preferred serialization is using only definite length strings, arrays, and maps. Those are all fairly straightforward things we know about. And then the third part of preferred serialization is the unification of the integer and big number spaces. So that's preferred serialization as described in RFC 8949. Then deterministic serialization, which I'm just going to use the phrase deterministic serialization. All that does is take preferred serialization and adds map sorting. It's just very simple addition to preferred serialization. So then on the right, I've listed 6 things that I think are issues in RFC 8949. And I believe that the left part there, the gray and the blue, I think there's general agreement on that. I think only Anders maybe is the only one that would have any kind of comment on disagreement with that. It's like what to do. We know what to do. It's just how to write it up. What's happening in RFC 8949, it was a long time ago, and I mean, I was around for it, so I'm at fault for not saying something back then too, and all of that. So I'm not I'm just trying to work through and find a good path through here. So, starting from the bottom, I think that 8949 doesn't use normative language for preferred serialization, and it could. And I think there's too much sort of background asides and context mixed in with the requirements. So I prefer, bullet lists of normative requirements. The other thing that goes on in 8949 is that this is kind of described out of order. There's sort of a normative list for the deterministic serialization that's kind of the preferred serialization, and it's not stated in a clean way like this, where it can be. You can just go boom, 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 and then deterministic serialization adds map sorting, right? Then in the unification of integers and big numbers, there's just some things that are not clear in there that could be made more clear. It's just a matter of clear writing. One of the other problems is the factoring in 8949 misses reference to the unification of integer and big number, the big number unification. Then the next one up, definite lengths are preferred in 8949, not a requirement. And then the last one is there's some issues with NAND payloads in 8949. So what I would say is you look at this list and all of the issues are in the structure and in preferred serialization. The deterministic part is the easy part, the straightforward part. So that's why I've kind of gone off and written my own document on serialization that structures it this way. It's where the focus is serialization, and the easy part is deterministic serialization just becomes add map sorting. So it seems like a much more clean thing. It took me like 2 years of thinking and, irritating a lot of people in this room to educate myself to be able to get to it. This seems clean and clear to me. And then I'm going to make another comment here on the CDE, a couple comments on the CDE document. It seems like it started out as a profile document to deal with things like CBOR, not to articulate this. So that's why it's off on the wrong foot. And I'm looking for a really different structure. The other thing I want to say about CDE is I have I made quite a number of comments on the CDE document, posted to the list, put a lot of work into it, and they are unacknowledged in any of the issue tracking or anything like that here. So, okay, thank you.
Okay, Carsten.
Carsten Bormann. As an editor, I really like actionable comments because I can apply them, maybe fix some of the wording, and we're done. The problem is, if this is the basis of your comments, I cannot use them because almost everything on this slide is wrong. It's wrong just subtly, but it's wrong enough that we cannot publish a standards document based on what's on there. So first of all, preferred serialization is defined in 8949. It was maybe stupid to define it the way we did, but we defined it that way. And I see absolutely no reason to come up with a new definition of this term. It's in STD 94, and we should continue to use it with all its limitations. It's not wrong, it's just a term, and we defined it that way. So that's observation number one. There are several places where you say things are unclear. Well, you have to read the thing to find those pieces. And I think the most, well, not really actionable, but the most specific comment was, oh, that's in another section than 4.2. Well, yeah, you really have to read the whole document. That's maybe an unfortunate property of 8949.
So, but let me interrupt at that point and say that one of the comments that's being made is that the document would benefit from reorganization to avoid those issues. And
I'm talking about
that's
8949.
a discussion we need to have.
What is this document?
The CDE.
Okay, I absolutely acknowledge that there would be benefit from doing another editorial review, but I would like to understand the target of that review. Mm-hmm. And the target will not be rewriting 8949 and doing a new revision of 8949. That doesn't make sense. The target should be to write up what's in 8949 that is relevant for common deterministic encoding, and make sure that this mentions all the issues and tells people how we are handling this. So there's a certain minimal amount of implementation advice in there, but it's mainly just pointing to the right sections in 8949 and telling people, oh, that's what's in there, and here's a little summary of what that is. And I think what's missing maybe, and that's maybe another editorial action that I need to take, is being very specific about no new normative content. Some things are clarified a little bit, yes, but yeah, so if we can agree that 8949 does not need to be revised, then that will simplify things a bit. And the other part is if we can agree that the CDE document should be useful for doing deterministic encoding, for doing the common deterministic encoding that has resulted from a few years of experience with what's in 8949, then we have a clear target for this effort.
So as the other commenters come up, I would like to hear at least agreement or disagreement with Karsten's desire to keep 8949 the way it is, and just you're just addressing issues in the CDE draft, or you think we really need to revisit 8949. I'd like to hear it one way or the other on that. So anyway, go ahead, Rowan.
Hi, Rowan. I think that there's a simple way to find out if people think it's clear, which is to do a show of hands. Because I think if I go out in the hallway and I get 10 people at random who are all protocol engineers, and I ask them to read that section in 8949, I think they're going to have some of these questions. They're going to be confused. Now, I could be wrong, but we can do a show of hands and find out.
All right, I am typing up a show of hands
And,
now.
and even if
I just did.
Okay, Christian did it. So we have a show of hands up. Do you think there need to be normative updates to 8949? Yes, no, no opinion. And we're getting a couple of yeses and a bunch of no's.
And I want to be clear that I think the intention, I don't think we want to change the intention of what that document said. It's just, I think that there's some stuff that's not very clear.
Mostly no and no opinion, but there are a few yeses that we need to make normative updates to 8949. But so to me, that what you said not clear is to me different from normative updates.
I mean, personally, I think that we would end up with a better result if we did a document that says updates 8949.
That's the
But
CDE document.
the CDE
should
document.
update 8949.
However, this shows, in my opinion, that's rough consensus to not to do that.
I don't completely agree with that statement. I think it depends what the four people who said yes want to change. We would need to discuss the details to decide where the rough consensus is. Ori.
Hi, Ori Steele as an individual. With this graphic on the left-hand side, I was looking at you when it came, Karsten, I was looking at you when it came up, and I'm wondering, is the graphic on the left-hand side something that everyone agrees with? Because what I heard you say is that the issues on the right-hand side are difficult to figure out what proposed changes, what text you would, what would you do with the yellow boxes? But is the left-hand side of this picture something that there could be some consensus that this is good enough, perhaps to even include as a diagram in the CDE document? Thanks.
So the left-hand side of that diagram has a simplification. By redefining the term preferred serialization, you save introducing one additional term. And what I would really like to stick to is the definition of preferred serialization that everybody knows, and that is in 8949. And that is unfortunately orthogonal to indefinite length encoding. So if you modify this picture by adding this new term, which is right now basic serialization, and pulling the vertical bars, then it's exactly what we are doing.
So can you produce a modified version of a diagram like this for us? Awesome, thanks.
Lawrence.
Yeah, so the document I authored, I wrote it as an update to RFC 8949. And I did that because I really wanted to sort of write this down as if sort of it was greenfield, like if we were starting with what we know today and we were going to write it as clear as possible. So I wrote it in that style, and for the sake of clarity and understanding. Maybe the working group decides to use that text or something like that, or structure it like that, and maybe it's not an actual update to RFC 8949. What I'm after here is the clarity, is as the main goal. It's about the clarity, to try and find a way to be clear, rather than like, I'm not, set on it having to be an update to 8949.
Yep. Rowan? No? Francesca?
Okay, thank you, Francesca. I just wanted to say, I reacted to something you said, Rowan. You said, I believe, about updating, and that you wanted to see it update RC 8949. And I just wanted to mention that the update tag is like so undefined that it could mean anything and everything. It really can mean anything. So it's not really clear when you said, like, I want to use that tag. To me, it's not very clear what that means, because that tag can mean anything you want. Yeah, maybe just to understand what you meant by that, because from what I've heard, I heard only like issues with clarifications, and also you, Lawrence, were saying this is not clear. And when I say this, I mean, I guess 8949 and partly also CDE, because that doesn't solve, yeah. So like, I don't hear, and I hear Karsten saying what is on the slide would change the content that is already defined in 8949, and I hear him object to that, but the comments that I hear from others is more, we don't necessarily want to change the content, but what is there is not clear right now, so there is at least editorial modifications. And please correct me if I misinterpreted anything. And
Yeah. So the fact that we have a statement like, saying that that definite lengths are preferred, for example, like that's a meaningless thing, right? So it should either say you can use definite or indefinite lengths, or it should say only use definite lengths. And so if I were going to say like the meaning of updates that I would apply would be just to say, okay, what I would recommend would just be, if it were entirely up to me, I would just go and rewrite the section that says, okay, here are the serialization types that we define here. Applications can define profiles, but these are the ones that are defined here. And this completely replaces that section in the RFC. Now, if people don't want to do that, I understand, and I'm going to shut up.
Chris?
Yeah, so we have, I've struggled with this a little bit, trying to use this encoding in another specification I wrote. And so I've actually done the, carefully read 8949 and all of the other options to figure out which encoding I actually needed for my protocol. And first of all, I don't think I came to the same conclusion as the picture on this slide. And the fact that I didn't come to the same conclusion as the picture on the slide suggests that there is at least confusion, right? I'm not sure that the 8949 is wrong. I think that it's normal that it specifies a implementable and normatively correct set of things. And I don't necessarily know that it needs to be revised, but there is significant confusion about these details, and some way of resolving that confusion would be good. It doesn't have to necessarily be editorial updates to 8949. It could theoretically be some other document. I mean, Karsten could put up a blog post that explains to us, how it actually works with citations to the document. But some way of clarifying the confusion would be of benefit to the protocol writing community.
Okay, Karsten?
Yeah, so that some way, I think it's a VCP. I have a precedent for that. You know that there is a body of documents that define the Jose standard. And that body of documents made a few assumptions about the knowledge of people who would be implementing it and using their implementations that turned out to be a little bit optimistic. So they actually wrote a BCP on how to use this stuff. And that was wildly successful because it answered all the blank spaces in the brains of the people who read Jose and didn't do what every security RFC reader needs to do, which is reading 1,000 other RFCs so they can understand what's in there. And that's a very similar situation to what we have here. You can read 8949, and if you do this properly, you probably will get at the same result. But it's nice to actually write this up in concise form. And yes, I hear your comments about conciseness, so maybe that's work to be done. But the point is this concise definition also should have some background material so you have a chance to understand it. We shouldn't try to again produce text that is just barely self-sufficient, and then we will need another BCP a few years later. So that's why I think doing this as a BCP is the correct way. People who are right now referencing 8949 in their SDO documents don't have to think about what those updates to 8949 mean to them, because there will be no updates. People who need a document, who are writing a new document and need a document to refer to, can just point to the BCP because it has all the normative references to other documents that are useful in this space. So just looking at the outcome in the CBOR ecosystem, having a document that clearly says we are not changing our common deterministic encoding, but we are documenting it in a more accessible way, and we are clarifying a few things that will help you when implementing and using it. That is probably going to have the best outcome for the CBOR community.
Lawrence?
So again, I'm not, if it's a BCP or an update, I'm not really set on any particular type of document here. That's maybe up to the, I don't know, the document nerds that really care about that sort of thing. What I wanted to do was write the requirements for the stack there on the left in bullet points using RFC 2119 language, and be very sharp and very clear of the requirements. And then actually I agree that explanatory background information is great, but keep it separate. So when you're an implementer and you're reading it and you want to know exactly what I need to do, you can find the clear requirements. So that's, so I wrote this, and that style of listing the requirements actually exists in the CDE document, but they are as an implementer's checklist. And I was hoping that it would become more in the CDE document, but that wasn't the way Karsten integrated it. So then I took that 2119 style definition of those requirements, and then I put that in my own serialization document. So I have, which I've published as a draft, and it's out there. So that's really the style I'm looking for, is in the clarity in there. So that, I've been kicking around an articulation of this in kind of 2119 bullet points. That's really the clarity I'm after, and we can put the context, background, keep it separate, right? So another thing I want to speak to here is that, Karsten asks for actionable comments on CDE. I mean, to me, I try to do that, but in some ways, to me, some of it is about very large structure of the document, very large approach of the document. So I've tried to provide background and a clean, clear way to say that. But I put work into it to try to make those comments the way I want, but I know they're not landing for Karsten the way he wants them to be actionable. So.
Okay, before we get the last comment from Nikolai, you can go ahead and get up to the microphone while I'm saying this. I propose that that one way to make this actionable is to have Rowan, Lawrence, and Karsten get together between now and the next interim call and work out among yourselves whether you think you can get together and turn this into I would call it an applicability statement rather than a BCP, but make an applicability statement that clarifies 89, whatever it is, 8949, and organizes this in a way that you can all live with and that you all think is clear. Are you guys willing to try to do that? I'm just looking for nods or thumbs up, sir. Karsten, work for you? Yes, that's exactly what preferred to, oh, a different thing. Okay, so that's what I asked the three of you to do in the next couple of weeks. Nikolai, last call.
Yeah, I just wanted to point out, I can relate a bit to this whole discussion because when I first read the draft, I think some like 9 months ago, I also got a bit confused about the content, and that led to some suggestions, and some of them, or I think most of them, got incorporated, and one of them is being table 1, which is basically what we have here on the slide, just that the definite length encoding is sorted correctly. So maybe if that's still not clear enough to some people, then that would be some point where we could work on to improve. But like for me, after having these suggestions incorporated and having spent the time to understand the document before, it was clear enough. So, but maybe now I have a different view on it because I spent some time working on it.
Okay, thanks for that. So the thing that I do see that we have consensus on is that there are things that are unclear that need to be clarified and reorganized. So let's see if we can do that and wrap this up in a reasonable time. And we are out of time now. Thanks for the discussion. Thanks for attending. And Marco and Christian, thanks for the notes you've taken. It's always helpful. We will see you in a few weeks on the interim call.
Thank you all.
Yeah.